So let's calculate the pH when strong acid and bases are mixed together. Strong acid plus strong base. Whenever we mix a strong acid with a strong base, let's see what could be the pH. So let's say we have a strong acid that has a molarity M1 and volume V1, which gives the OH positive. We have a strong base which has a molarity M2, volume V2, which gives OH negative. So from here we can predict the millimoles of H plus. If we talk about the, let's say, volume, might be in milliliter. So M1 V1, so it will be A value, let's say. And millimoles of OH negative, it is M2 V2, it is B. So now let's talk about some cases when millimoles of A and B could be varying. Might be A is more and B is less, B is more, A is less, and both are equal. So how do we calculate pH? Remember, we are only talking about right now specifically for strong acid and strong base. We are not including any weak part. When we include the weak part, the case will be different. It could be a salt hydrolysis or buffer. We can see further. But since we have seen a little bit of salt hydrolysis, that's why we can just calculate these type of problem. And when a strong acid is mixed with a strong base. So case 1 over here, let's say A is more, means acid is more millimoles of base, then the solution will be acidic. When the solution will be acidic, the concentration of H plus will be moles. If A is greater than B, so how much H plus will be negative? B will neutralize its equal amount of H plus in A. Now remaining will be A minus B. Because let's say A is 5 millimole and B is 3 millimole. So the remaining H plus will be 2 millimole, because 3 millimole of OH negative will neutralize 3 millimoles of H positive. Now divided by total volume will be V1 into V1 plus V2. Since we have mixed both the acid and base, the volume will be summation of the both. And similarly, OH negative in that case will be Kw over the H plus. Now let's take case 2. When B is greater than A, the base is greater than A, so it is called the basic solution. The solution is basic. Now similarly, in that case, the OH negative will be B minus A over the V1 plus V2, and the concentration of H plus comes out to be Kw over the OH negative. Now case 3, when both are equal, A equals to B, then that will be case of salt hydrolysis. In the series of calculating the pH of salt hydrolysis, first of all, we predicted that when when a strong acid and a strong base are mixed in unequal amount, how do we calculate the pH? So let's talk about a question. So in that question, it is given 200 ml of 0.1 molar HCl is mixed with 300 ml of 0.1 molar NaOH. Calculate the pH of the solution. In order to calculate the pH of solution, let's talk about the moles of A positive, H positive. So let's since we have write that down, what is the A and B. So A is 200 into 0.1, so it is 20, and B is 300 into 0.1, so it is 13. So concentration of since the B value is more, so concentration of OH minus, we have to calculate the solution will be basic in nature. So it will be 30 minus 20 over the total volume is 500 ml. So it is 500. So it is 2 into 10 to the power negative 3. So POH comes out to be 3 negative log 2, that is 2.7. So pH comes out to be 11.3. Now one more problem. The question says calculate a value of 0.1 molar NaOH which should be added in 300 ml of HCl solution having pH 2 to change its pH by 2 unit. What does it mean? It means it is trying to say that we have 300 ml of HCl solution and its pH is 2 and its pH is 2. Now we are adding 0.1 molar NaOH and it has some volume. It has some volume and we are adding 0.1 molar NaOH. So we have to calculate the volume. Now let's understand. It is only saying to change the pH. Now initially its pH is 2. Now we are adding base. Obviously pH will increase. So pH final will be 2 plus 2, that is 4. Because we are adding the NaOH, so we know the concentration of H plus in the final solution, that is 10 raised to power negative of 4. Now let's talk about what is A. A is, let's say V volume we are adding. And so A is we use for like acid and B we use for base. So A is 300 ml of HCl solution and the concentration is 10 raised to A is actually the concentration the millimoles of HCl. pH is 2, then concentration of HCl should also be 10 raised to power minus 2 because the concentration of H plus is same as the concentration of HCl. So it is 10 raised to power minus 2 because pH is given 2. So A plus will be 300, its volume ml into concentration of HCl is 10 raised to power minus 2. So it is 3. And B is, let's say its volume is 0.1 V. So the concentration of that H plus is 10 raised to power negative 4. That was A was 3 minus B 0.1 V over the root over 300 ml plus V volume is been added. So now let's solve for V. So if you multiply both of them, it will be on 0.03 plus 10 raised to power negative 4 V 3 minus 0.1 V. So here V is coming out over 2.97 over 0.1001, 29.7 ml.